All right, in this note, we are going to cover odd and even functions. There is actually a third category, and that is not being odd and not being even. So there is a neither category. And this works for polynomial functions, but it also works for every other function. It actually works for non-functions, so it works for relations. Relations are pictures that don't pass the vertical line test from grade 11. So this course is all about functions. So we're going to talk about it. Now the first thing I'm going to do is I'm going to go through both odd and even, and indirectly I'm going through neither, and show you what it means as a picture, so as a graph, and then, which is the blue and the purple on this sheet, then I will come back and talk to you about the test, which is figuring out whether a function is odd or even or neither, but doing it algebraically. So without having to go to the trouble of drawing a picture, or without me going to the trouble of drawing a picture or finding a picture. So a function is considered odd if it is symmetric with respect to the origin. Now, you can look at that a couple of different ways. I'm going to show you a couple of different ways with both these pictures. We'll look at the one on the left first, and I think my smartboard magic will let me do what I need to. So what I'm going to do is I'm going to take this function and I'm going to outline it as good as I can with a colored pen. So that's not bad. I'm not really concerned about the arrows, I'm just concerned about the shape. And this is not a polynomial function that you'd ever be expected to draw, but I could give you a graph very easily. And remember, this isn't just for polynomials, this is for a whole bunch of functions that you have no experience with yet. So with respect to the origin means that if I pick up any spot on this curve and I rotate it, and I rotate it 180 degrees, it lands on itself. Now this doesn't exactly land on itself, and the reason it doesn't is because my curve and my grid, for that matter, aren't completely at right angles, so it doesn't work out perfectly, but that's the general idea. Same kind of thing here when we do it. Now another way to look at it is if you flip the curve up and down and then flip it left to right, does it land on itself? And if the answer is yes, then you have an odd function. So if we look at the four quadrants, this is 1, this is 2, this is 3, this is 4, basically what I'm saying is that 1 and 3 are exactly mirror images of each other. And 2 with quadrant 4 are also going to land on each other. So that rotation will happen. Now I'm going to get rid of that, meaning I have to delete it. And then I'm going to do the same thing with this picture just to show you what's going on. So this is a picture that you should be familiar with from grade 11. It is the basic y equals x cubed graph, and as you can tell, I'm not being fantastic with that. Not going to worry about the arrows. And again, I'm going to do both versions. I'm going to take this and I'm going to rotate it 180 degrees, and it doesn't matter if I rotate clockwise or counterclockwise, but if it, holy, that's awesome. If it lands on itself after you do that rotation, then you're good. So I'm going to put that back, and then I'm going to do the flip. Now I said with this one, up, down, then left, right. I'm going to mess with this one and do the left-right first and the up-down second, because it really doesn't matter as long as you pull off both of them. So that does land on itself. This did land on itself. That means these two are perfect examples of odd functions. I'm going to get rid of that. And then we're going to go on to even. And even is a little bit easier. And remember, if it doesn't fit into this rotational description or this one, then you just file it under neither. Now, an even function is if it is symmetric with respect to the y-axis. So that means if I dig out a color and try to map this, okay, I didn't do a fantastic job. Oh. And I have to do it all at once. Otherwise it won't be attached to each other. Better. So this is a little bit easier, or maybe a lot easier, depending on you. And remember, I will come back to the test. If this is flipped over the y-axis only, so there is no definition for anything that is reflected just over the x-axis, it's either flipped left to right and lands on itself. Again, it's because my thing isn't square. Or if it's a double, or that rotation. Here is y equals x squared from grade 10 and grade 11. Oh, that's terrible. But either way, I think you get the general idea that if I take this and I flip it over the y-axis, so left-right, it would land on itself if I had had this done properly. And if my outlining was better. So you can, depending on your ability to look at pictures, you can just look at pictures and state whether they are odd or even. And I'm being an absolutely terrible math teacher because I keep calling these things pictures when really they are graphs. And what we do is we don't draw pictures, we graph or sketch. So I'm being kind of awful about this. Now I do want to take a look at this test now because we don't want to have to draw these pictures and go through all the steps it takes to find all the characteristics of a polynomial function, or even worse, some of the other crazier functions that we deal with. Instead, we might want to take care of this algebraically. Now I want to do a little flip. Actually, let's see if I can do this. I'm going to try the dual page display and see what happens here. Okay, good. So what I want you to notice is that the test, whether it's odd or whether it's even, is exactly the same. You're taking the equation for f at x, and instead of using x, you are going to sub in negative x, regardless of which one you're looking for. Then, if the result ends up as the original, but all negative, then you have an odd function. If the original, after you sub in negative x, ends up not changing at all, then you have an even function. And if it doesn't fit exactly into one of these categories, then you have neither. So we're going to go through all this. I'm going to erase my markings. May need to come back and put them on. But my first question will need me to put this back on full screen. Not what I was intending. Put it back on entire page. Single page display. And page 3. Now, once upon a time, I did this with Supply Teacher. So I've got all these boxes. So I'm going to do what my high school teachers used to do, and that is I'm going to pull the boxes along and show you step by step what exactly is going on. And I used to hate this, only back in the olden days, it was with the overhead and a piece of paper. So at some point, I will start uncovering all this information and tell you what's up. So step number one. Step number one is you do the test, which is taking all the x's and turning them into negative x's. So that's step one, regardless of whether you're talking about odd functions, even functions, or neither. Next thing is you clean it up. This is my little note to you. You actually tell me you're putting in the negative x, and then you put in the negative x everywhere there's an x. Now the next step. Step number two is to simplify the expression. So I may need to dig out my pen here, because usually when I'm in a class, this is where I dig out my pen. So I'm going to use green just for kicks. So negative x multiplied by negative x multiplied by negative x multiplied by negative x, which is exactly what negative x to the fourth is x times x times x times x, which is x to the fourth, and 4 negatives being multiplied by each other. So these two negatives will cancel out and become a positive. These two negatives will cancel out and become a positive. So this whole quantity is actually positive, which is why I can simplify negative x in a bracket to the fourth to just being x to the fourth. And similarly, I can take negative x squared and I can do the same thing. So a negative and a negative makes a positive. X times x is x squared. This plus sign comes down. So step one, we insert the negative x. Step two, we simplify the expression as much as we can. So I've just made a little note here, since in both cases a negative value is being squared. I guess this one to the fourth, so it's squared twice. It will result in a positive value. So now let's see what's under the next box. Not what I intended. I don't know why I don't listen to myself sometimes. There, I do it again. So this function is even, and the reason this is even is my blue writing here. So step three, after you've simplified the expression, is to decide whether your result shows even, shows odd, or shows none of the above. So if the resulting function looks exactly like the original function, that means the original function is even. So that's why I've said this. If you need to know where I found that, it's here. It says when you put in a negative x for all the x's, there is no change at all. So that was under even. This means that if you graphed or sketched this particular, in this case, a polynomial function, it would be reflected perfectly over the y-axis. So it wouldn't be either one of these pictures, but it would work just like these pictures, just a sideways flip. So now let's look at a second question. So the second question is exactly the same, and I'm hoping that at some point you can look at a question, at least in polynomial functions. I hope that you can look at a function and just be able to tell me whether it's odd or even though you need the work. You need to show the work for the marks, and because someday you're going to get something far more complicated than what I'm giving you today. So, step one, after you get the function, step one is you take every x and replace it with a negative x. Every single one of them. So we've got one here, and we've got one here. You tell me you're doing it, then you actually do it. Then you clean it up, so you simplify the expression. So I'm going to do my little scribblies here. So negative x to the 3 is negative x times negative x, which is positive x squared, times another negative x is negative x cubed. So there's the x cubed from the x times x times x, and then a negative times a negative times a negative is a negative, so we can sit it on the outside of the bracket or no bracket at all. Then here, this should be pretty easy. Positive 2 times negative x is negative 2x. So, since in both cases there are odd number of negative values, it will result in a negative value. So, odd number of negative values results in a negative. This is odd because it's 1. Negative value results in a negative value. Now, under the big box. See, I learned. This function is odd. So if I compare this to the original, it is exactly the same as the original, except all the signs are changed. Another way to write that would be negative common factored out. Now if you take a look at this bracket, this quantity, is exactly the same as the original with a negative out front. So decision time is always step 3. If the resulting function looks like the original function except all the signs have changed, or that you can common factor out a negative and all the signs are the same, then you have an original function being odd. So that means that if you took this polynomial function, and remember they aren't always polynomial, but if you took this polynomial function and you did all the stuff that we did from the polynomial functions unit to find the characteristics, and then you graphed or sketched it, it would be perfectly reflected over the origin. So it would do the double flip or the swing around, and it would land perfectly on itself. So in writing, that looks like this. I'm taking all the x's, turning them into negative x's. I end up with the original with a negative out front, which is the common factored version. If you prefer not to common factor, then that means this happens, meaning you have a negative version of the original. So, a couple more questions. I'm hoping that you can look at this question and see whether it's odd, even, or neither. So, step number 1, take every single x and replace it with a bracket of negative x. So there it is with the 5 exponent on the outside. There's the negative 2. That x is replaced with the negative x squared. This plus sign gets written down again, and then this x gets replaced with a negative x. And then we can clean it up. Now some of you are going to be able to clean this up in your head. Some of you are going to require some scribbles off to the side. So if you need to write negative x times negative x times negative x times negative x times negative x 5 times to figure out that it's x to the 5 with a remaining negative, then do it. Here you have negative x squared, which is positive, but it's made negative by the negative 2 out front. And then finally, positive times a negative, no exponent, is a negative. And if you take a look at that and compare it to the original, the first term changed signs, the last term changed signs, the middle term did not change signs. So this isn't even, because it isn't exactly the same, and it isn't actually odd either, because if it was odd, every sign would have changed. So that means I get to say it's not odd or even, or I can say it's neither. So there's what I just finished saying. If it had been even, we would have ended up with the original as our answer. And if it was odd, this term would have been negative, this term would have been positive, this term would have been negative. And we only have 2 out of 3, and that's not good enough. So this is the hardest one. Because although you may say to yourself, oh, okay, well I can just FOIL that. What would happen if I put a little 17 up here? Would you really want to FOIL that out 17 times and then multiply it by this, multiply it out 12 times? No, you have to find a different way of approaching it. But your steps are the same. So step number 1, take every x and turn it into a negative x. So here it is. We don't need brackets because there's nothing out front of that x. Here's the minus 5. This x turns into a negative x. There's the plus 2. Then we have to take, or I've decided to take a negative out of this bracket. So that means there's the negative, and both of these are now positive, and I put a square bracket around that quantity. and I've decided to take a negative out of this bracket, which makes this positive and this negative. So I've basically removed a common factor of -1, which I wrote slightly differently there. Now I can take this -1 and multiply it by this -1, brackets remaining the same. -1 times -1 is +1. That means I don't have to write it down at all, and x plus 5 gets repeated and x minus 2 gets repeated. So now let's look at why I've got a therefore statement that says this is not odd and it's also not even. If it was even, which is pretty easy to determine, you would have ended up with this, as in you would have ended up having the end result be the same as the original. If it was odd, you would have a bracket of x minus 5 and a bracket of x plus 2 with a negative out front. So other versions of that would be you multiplying in a negative into the first bracket and leaving the second one alone. Another possibility would have been you leaving the first bracket alone and multiplying a negative into the second bracket, because you're only allowed to pick one or the other. And neither one, I guess none of these three are what's sitting here, so that means it's not odd. So if it's not odd and it's not even, then you have to say it's neither, or you can make a full-blown statement that says it's not odd and it's not even. So that is your odd-even note. On the Google site, there are some supplemental worksheets that I found online that I quite liked, so I put them there so you can look at it and maybe spruce yourself up a little bit if this isn't enough for you. But in your work booklets, it's the second last sheet in your booklet. I think the answers are on the last sheet, but I'm not 100% sure. But that's how this works. So that is it. And I set new records with this. Yay me. Have a good night.